Hello everyone and welcome back to another video. Today we're going to change things up and do a quick review of trigonometry, as well as head into a couple of problems dealing with multiple triangles. First of all, let's take a look at the acronym that we can use to help us use the trig ratios. We have SOHCAHTOA, which is SO, sine, which is opposite over hypotenuse. We have CA, which is adjacent over hypotenuse for your cosine ratio. And then finally, we have TOA, which is your tangent ratio of opposite over adjacent. So putting that all together, we have SOHCAHTOA. Now, how do we use this acronym or these ratios to help us figure out different side lengths and angles? Let's go ahead and start off with the sine ratio, which is the opposite over hypotenuse. If we have angle here in the bottom right-hand corner, then we'd be looking at the opposite and the hypotenuse. What the sine ratio does is it tells us that if I know, for example, the angle A and the opposite side, I can use the sine ratio to help us find the hypotenuse. Alternatively, if I knew the hypotenuse and I'm trying to find the opposite side, then I would still be able to use the sine ratio. Last but not least, if I know both the opposite and hypotenuse, then I can use that ratio of the two sides to help me find whatever angle A is. We can do the same thing with the cosine ratio. So moving on to the second triangle, I have my adjacent side and then my hypotenuse. So if I have one or the other here, if I know the hypotenuse and I know the angle, then I can figure out the adjacent side. And if I know the adjacent side and the angle, then I can find out what the hypotenuse is. And then if I knew the two sides, the hypotenuse and the adjacent side, I can find out what my angle is. Last but not least, we have the tangent ratio. So here I would use my opposite side and my adjacent side. So from here, if I knew the angle and I knew the opposite side, I'd be able to find my adjacent side. And if I knew my adjacent side and my angle, then I can find the opposite side. And if I knew both sides here, I can use that to help me find whatever the angle is. So just to recap, using this ratio again, I need at least 2 out of 3 things. This would be number 1, number 2, and number 3. So I need to know at least 2 out of 3. So if I know the angle and I know the opposite side, and I'm trying to find the hypotenuse, then I can definitely use the sine ratio. But let's say I was actually trying to find the adjacent side and I knew the opposite side, I knew the angle. Well, that gives us a clue that we're actually using the wrong ratio. If we're trying to find the adjacent side, then we'd actually be looking for the tangent ratio. So that's typically the trickiest part about using your trig ratios, identifying which one is the correct one to use. Let's start off with the sine ratio as an example. Let's say I have the sine of angle A is equal to opposite over hypotenuse. And in this case, I'm going to claim that this angle is 30 degrees. So that means that instead of having angle A, I'm going to have the angle of 30 degrees there. And that's still equal to opposite over hypotenuse. So given that I already know that I have an angle of 30 degrees, I need to figure out what the ratio of the opposite side divided by the hypotenuse is. When you punch in sine of 30 into your calculator, what it actually does is it gives you this ratio here. So if you were to punch it into your calculator, sine of 30, you actually get 0.5. So sine of 30 is equal to 0.5. What that means is that this ratio of opposite over hypotenuse has to be 0.5 if your angle is 30 degrees. So what that really means is that this side could be 1 and this side could be 2. We could also have alternative triangles where this could be 2 and that's 4. We could have something like 5 and 10. As long as we know we're looking at this angle here, this angle has to be 30 degrees in all these cases. So if the ratio of the opposite over the hypotenuse is 1/2 or 0.5, then that corresponding angle has to be 30 degrees. We can go ahead and use another example of, let's say, tangent of some angles. Tangent of angle A is equal to opposite over adjacent. So let's say we have this triangle here, and I've got angle A in this corner this time, and this is 45 degrees. If I were to punch in tangent of 45 into my calculator, and I'm just going to put opposite over adjacent here, tan of 45 is actually equal to 1. So tan of 45 is equal to 1. Well, what does that mean about my ratio then? That just means that the ratio of my opposite to adjacent side has to equal to 1. So in plain old English, that means that for any angle or any triangle to have a 45-degree angle here, the ratio of the opposite over adjacent side has to be 1. So these two sides could be 1 and 1 perhaps. It could be 5 and 5. It could be 100 and 100. As long as the ratio between those two sides is equal to 1, then I know for sure that this angle here in the corner has to be equal to 45 degrees. And that's the beauty of using these trig ratios. Alternatively, let's say, for example, I know what my ratio is, but I don't know what the angle is. Trig ratios are nice because we can actually work backwards using our ratios. So once again, let's say we know our ratio is 1 and we need to figure out whatever the angle is. Well, in order to get that angle, what we're going to do is we're going to take the inverse tangent of both sides. So it would look kind of like this, the inverse tangent of 1, and we actually get 45 degrees as our answer. Same thing with the previous sine example. If I took the inverse sine of 0.5, so I'm going to take the inverse sine of 0.5, we end up with 30 degrees. So once again, just to recap, if you know 2 out of 3 things in any trig ratio, so again, if I know 1, 2 out of those 3, I can find that third one. If I know 1 and 2, then I can find out this third one. And if I know 1 and 2, I can find out the angle there. One last thing before we move on to some multiple triangle examples. Let's figure out what the difference is between the regular functions, so like tan, cosine, and sine, versus your inverse tan, your inverse cosine, and your inverse sine. How do you know when to use each one? So basically what this breaks down to is if you want an angle, then you want to be using these inverse functions. So what that would kind of look like is, let's say we start off with your typical ratio. We have tangent of A is equal to opposite over adjacent. Then we would take the inverse tangent of opposite over adjacent, which really can be simplified into your angle is your inverse tangent of some ratio. Now, if we want the ratio, what we're going to do is we're going to use the regular functions. So what this is going to look like is if, let's say we have tangent of A, maybe I'll do this in green. Tangent of A is equal to opposite over adjacent. And I know whatever my angle is, so tangent of perhaps 45, this will give me whatever the ratio is. So I know that tan of 45 is equal to 1. So whatever the opposite over adjacent is going to give me my ratio. So essentially, if we want to come up with a pretty general formula, if we take the tangent of some angle, it gives us the corresponding ratio that's attached to that angle. So moving on to problems with 2 or more triangles, there's typically 3 scenarios that you'll have to deal with. First, you might have to find the shared side length and using that value to go further. You might have to find 2 side lengths and subtract them, or you might need to find 2 side lengths and add them. So to kind of illustrate what that would look like, let's say we have a triangle that looks kind of like this, and maybe I'll do this in black. So I might have something that looks like this. I've got this side length here in the middle, so we actually have 2 right triangles here. And we need to find this side length here to help us continue on in the problem. That would be scenario number 1. In scenario number 2, we might have one big right triangle and this smaller one here. So we actually have 2 triangles. We have really this one here on the outside, that blue one. And then we could also have this green one that'll be right there. So we actually are working with 2 triangles, even though it looks just like one. And what this is going to do is if you're going to subtract them, we'd be asked essentially to find this side. So let's say we gave these points here. So we have A, B, and C. In order to find BC, we have to first find AC and then subtract AB from it in order to leave us with the leftover, which is BC. And last but not least, we might need to find two side lengths and add them. So we might end up with a problem that may look something like this, and you'll have to add up perhaps these two vertical pieces or these two vertical legs of both triangles here. Just as a quick review, our angle of elevation has to be this guy right here. So we have our angle of elevation or angle of inclination. So that'll be this guy here. And then this guy down here is what we call your angle of depression. So starting off with our first problem, typically what I tell students to work with here is to come up with a plan before you actually get started. Identify what you know, identify what you don't know, and figure out a roadmap of how you're going to get there. So taking a look at our objective here, we're going to try to find XY. So let's go ahead and highlight XY here. So XY is going to be this guy right there. And we know that for any side length that we're trying to find, we need two things. We need, first of all, a known angle, which we do have. That's the 22. And we need another side length that we know. Well, unfortunately, we don't know XW and we don't know YW. But thankfully, we know that we're dealing with a double triangle situation here. So we're going to look at the shared side length, which in this case is YW. So we're going to actually need to find the length of this green side before we can actually progress any further. So to find this green side length, we need to have a known angle. So we have the 20, and we need a known side length. So we're going to work with this smaller triangle first. I'm going to go ahead and draw the triangle here. So I've got my 20 degrees in the corner. I've got angle Z there. I've got 8.4 over here, and I've got X, which is this side that I want to find. So let's label the two sides that we're working with. So the opposite side is what we're trying to find out, and we have our hypotenuse here. So I am going to be working with the sine ratio. So sine of angle Z is equal to opposite over hypotenuse. I'm going to replace everything that I know. So I have sine of 20 is equal to X over 8.4. Now I'm going to multiply both sides by 8.4 to isolate for X. So I'll multiply that side by 8.4, and I'm going to multiply this side by 8.4. So I get rid of the 8.4 on the left-hand side, and I am left with 8.4 times the sine of 20 is equal to X. So typically when you're working with these multi-triangle problems, you want to be taking any type of solution that's not your final answer and taking about 3 to 4. Typically I will recommend taking 4 decimal places. So on our calculator, we end up getting 2.872969. So I'll just go 297, just so we get a bit more there. So we've got 2.87297 as our value of X. So let's go ahead and put that up here, 2.897297. It does become a little bit tedious, but I only need to do this once. So now we're going to be working with the second triangle here. So let's go ahead and draw that one over here on the left. So I've got my 22 degrees, and I know that this is angle Y. I've got my 2.87297 here. I just realized I accidentally mislabeled this guy, so let's go ahead and fix that. So 2.87297. And we're trying to find out this guy right here. So let's call this guy, let's call this H. No particular reason why. All right, so let's go ahead and label the two sides. So if I'm using my reference angle of 22 degrees here, this side is my adjacent side, and this one happens to be my hypotenuse. So we're going to now be using the cosine ratio. So I have, let's separate that a little bit. Cosine of angle Y is equal to adjacent over hypotenuse. So cosine of 22 is equal to 2.87297 divided by H. We're going to use our little switcheroo trick so I can swap out your denominator here with the cos of 22. So I've got H is equal to 2.87297 over cos of 22. So I end up getting, if I round to the nearest tenth, 3.1 centimeters. So let's take a look at example number 2 here, where we need to try to find the height of the taller building. So typically for anything where we are working with the height of the taller building, we're usually going to be adding things together. So if I'm looking at the taller building, I'm really looking for this side length. And we'll notice that if we were to look at the other side of the building here, we have this top triangle and this bottom triangle. And really all we're trying to do is we're trying to find this guy plus this guy here. So let's go ahead and trace over those. So I need this red side, and then I also need this blue side. So red plus blue will give me the total height of your triangle. Now in order to get this red side length, I need to know two things. I need to know an angle, which I have, but I also need to know another side length. So unfortunately I don't have this hypotenuse here, nor do I have this bottom side. But luckily for us, this bottom side is a shared side length with the bottom triangle. So what we're going to look for is this guy right here, this green line. That's what we're going to be trying to get. And in order to find that green line, we notice here that we have the 15 degrees here, and we actually know that the blue side is 20 meters. So that blue side shares a side length of 20 meters. So let's go ahead and get started then with this bottom triangle. So I've got my blue and my green sides. I'm gonna go ahead and draw my triangle. I know that this is 20. This guy here is 15 degrees. I will call this angle A, and we can label our sides. So this is my opposite side, and this is the adjacent side. So we're gonna be using the tangent ratio. So tangent of angle A is equal to opposite over adjacent. So tangent of 15 is equal to 20 over, and let's call this guy here x. So 20 over x. We know that once we isolate for x, we get x is equal to 20 over the tangent of 15. And we end up getting x is equal to about 74.6410. So we're pretty safe just by going 641. And that's going to be in meters. So I'm going to go ahead and keep that for now. And we're going to move on to our second triangle, this red and green triangle. So let's go ahead and do that work over here. So I've got my red and I've got the green. And I know that this green side is 74.641. This red side, let's go ahead and call this guy y. Again, angle A. And this one from our angle of elevation is 30 degrees. So let's label based off of our reference angle of A. This is my opposite side, and this is my adjacent side. So I have tangent of A is equal to opposite over adjacent. Let's move this guy up a little bit. And I end up with tan of 30 is equal to y over 74.641. So to isolate for y, I'm going to multiply both sides by 74.641. So do that to both sides. So we'll end up with 74.641 times the tangent of 30, and that's equal to y. And we end up with 43.09 is y. And are we rounding to anything? Nearest tenth. So to the nearest tenth, we end up getting 43. Y is equal to 43.1 meters. So if we take a look at our taller building, we know that the taller building is going to be the blue line plus the red line. We know blue is 20, so we're going to add y. So we can say that the taller building, so tall building is equal to 20 plus y. So we have 20 plus 43.1. So we get 63.1 meters. So to end off with a sentence, the taller building is 63.1 meters tall. Let's check out this problem now where we're going to actually subtract two side lengths. So we need to find side m to n. So let's go ahead and highlight m to n. So we're going to look for this guy here. And we need to come up with a plan first. So kind of like what I've alluded to in my previous page where we talked about the 3 different scenarios, this will be that second one where we need to find the total side length. So we're going to actually find L to N first, and then we're going to subtract L to M. So here, let's go ahead and write our formula. So in order to find Mn, we're going to find Ln, and we're going to subtract Lm. That is the very first thing that we need to identify so that we can have an idea of which triangles we're going to use. So let's go ahead and find L to N first. So L to N, if I were to start off with my big triangle, we're going to use my angle of 20 degrees here. I have angle N in the corner, I've got my 90 degrees in the bottom left, and then I have my 10 meters over there. So we're trying to find this entire thing. So let's call this, we can just call this X. Maybe I'll do that up here. So we have L to N, which is just going to be represented as X. And we can go ahead and label each side. So I know I've got my opposite and my adjacent side. So I'm going to use my tan ratio. So tan of angle N is equal to opposite over adjacent. I've got tan of 20 is equal to 10 over X. So X is equal to 10 over tan 20. So I end up getting X is equal to 27.47477. So again, because this is not my final answer, I want to take 3, 4, 5, depending on what you feel like, that many decimal places, so we don't throw off the rounding of our final answer. Now I'm going to do the same thing with this second triangle because I'm going to try to find L to M now. So let's call this guy Y. So I'm going to make a second triangle here. And this one's going to be a little bit smaller. Now instead of using the 20 degrees, I'm going to use the 50 degrees because I'm now working with this smaller triangle. So 50 degrees, this is angle M, this is angle L. So that's in the corner, and I know that this is still my 10 meters. So we can label our 2 sides, and it just so happens that we're still working with the tangent ratio. So we've got opposite, we got my adjacent side here, and like I said, this is going to be that side Y that we're trying to find. And we're going to use that tangent ratio. So tan of angle M is equal to opposite over adjacent. So tan of 50 is equal to 10 over Y. So Y is equal to 10 over the tangent of 50. So we end up getting Y is equal to 8.39099. Now I'm starting to run out of room here, so I'm gonna have to squeeze this in. Maybe I'll shrink this guy just a little bit. Let me move this guy down a little bit. I don't need that. And I'll shrink this guy down. Oops. Let's shrink him a little bit. And we can see here that our original formula was just X minus Y. So Mn is equal to X minus Y. So Mn is equal to 27.47477 minus 8.39099. And we end up with a final answer of 19.08 as our answer, but we need to round to the nearest tenth. So we're saying that we're at about 19.1 meters. So this next question is a little bit tricky because we definitely need to keep our reading comprehension in mind here. We've got 2 buildings which are 85 yards apart. Oops, let me go ahead and highlight that. So we've got 2 buildings 85 yards apart. From one point, they should say on the smaller building, the angle of elevation to the top of the taller building is 27 degrees. From the same point to the base of the taller building, the angle of depression is 43 degrees. Find the height of the taller building. So what we're going to do is we're going to try to come up with 2 triangles with an angle of elevation of 27 degrees and an angle of elevation, or depression rather, of 43 degrees. So you want 2 right-angled triangles. So what I'm going to do first is I'm actually going to draw this line across, and this line is 85. So we know that this original green line here is 85 yards, which means that this guy is also 85 yards. So we're going to look at the first portion here. We have from one point of one point of the smaller building to the top of the taller building, the angle of elevation is going to be 27 degrees. So we're really just looking for this guy here. And we can go ahead and label this as 27 degrees. Now the tricky part is going to be this next section. And we have an angle of depression of 43 degrees. Now, again, we're going to draw my angle or my triangle looking like that. And where students typically make the mistake is labeling that 43 degrees. Here we know that our horizontal line is going to be this red line at 85 yards. So our angle of depression has to be this guy. So make sure that you keep that in mind as you are drawing your triangles. Now, if you can get to this part, you have basically solved the problem, because now we're just working with two triangles with our tangent ratios. If we're trying to find the height of the taller building, then essentially we're trying to find out this guy right here, and we're trying to find out this guy down here. So let's start with the upper triangle. So I've got the black, the blue, and let's go with the red. And we've got a couple of different measurements here. We've got the 27 degrees. I've got this guy as X. This side length here is 85 yards. I know that this is my opposite side and my adjacent side. And let's call this angle A out of habit. Tangent of A, because we've got opposite and adjacent, will be my ratio of choice. So tangent of 27 is equal to X over 85. I need to multiply both sides by 85 to isolate for X. So I've got 85 times the tangent of 27 is equal to X. And I end up getting about 43.30966. And let me move this over here so it's a bit more clear. So 43.39066. And this will be in yards. So I'm going to keep that for now. And then we're going to move over to the bottom triangle. So the bottom triangle, I've got my red side up top, which will still be the 85. I've got the purple here. And then let's go with my black here. And I know that this is Y. I've got my 85 up top. And this angle of depression was 43 degrees. And I'll call that angle A. We are working with the opposite side and the adjacent side. So once again, we're using the tangent ratio. So tangent of A is equal to opposite over adjacent. And let's fill those in. So tangent of 43 is equal to Y over 85. I'm going to multiply both sides here by 85 to isolate for Y. So I'll have 85 times the tangent of 43 is equal to Y. And I end up getting Y is equal to 79.26378. So to summarize my answer here, the tall building is going to be equal to X plus Y. So I get 43.30966 plus 79. Oops, that looks like a 2. 79.26378. And we get a grand total of 122.573. And we want our answer, that doesn't say what to round it to. So we'll just say we're going to round to the nearest whole number, roughly about 123 yards tall. So because we're dealing with a word problem, quick little sentence, the taller building is 123 yards tall. All right, so the final problem here that we're going to work through step by step is example number 5, where we have a fire ranger seeing two fires on opposite sides of a 40-meter tall tower. So that's going to be this tower right here in the middle. Doesn't seem like much. And then we have the one due west. That's going to be the one on the left. Has an angle of depression of 4 degrees. The one to the east has an angle of depression of 7 degrees. So we got 4 and 7 degrees. How far apart are the fires? All right, so there's a lot to process here. So first of all, let's go ahead and label that 40-meter tall tower right here in the middle. So that's 40 meters tall. And we want to try to figure out exactly what it is we're looking for. We're looking for this green line here. So let's say that this green section on the left is X, and the one on the right is Y. So we have two different side lengths that we're going to add together to find that total distance apart between the two fires. Now the part that's a little tricky is figuring out what or where do we put these angles of depression. So we've got two of them here. So we have one at 4 degrees going towards the left, and then 7 degrees for the one heading due east. So what we're going to do is we're going to go ahead and make our two triangles. So we've got one there, and we've got one kind of looks like that. All right. Now the problem is with this scenario here is that a lot of students, what they would right away decide to do is they would say, hey, we've got an angle of depression of 4 degrees. Well, this would be incorrect because we don't have a horizontal to work with yet. So actually what we'd want to do is we'd want to actually create a horizontal right along the top here. And what this does is we actually mimic the situation that's going on down there at the bottom, and we give ourselves that angle of depression up here. So this 4 degrees is my angle of depression, and we can go ahead and label this guy as 7 degrees. So really what's happening is we're creating a brand new set of triangles, which are really just upside down versions of the original two that we created. I can still say that this is 40 meters and this is still 40 meters. So the two triangles that we're actually looking at will be this one here and this one here. So we've got the yellow and the green triangles. And we can go ahead and label the top here as X and the top here as Y. So what we're gonna do is I'm gonna shrink this down a little bit so I give myself a little bit more room. So let's go ahead and do that. So let's move this guy over here. And let's start with the triangle on the left-hand side. So this yellow triangle here, I've got X on the top. I've got my 4 degrees here, and you guys will notice that this isn't really to scale. Like the 4 and the 7 degrees both look exactly the same. So don't worry about the scaling. You should never trust the scaling in pictures. So you got 40 meters over here on the left, and I'm gonna go ahead and label my two sides. So I've got opposite and adjacent. So I'm using my tangent ratio. So tan of, let's call this T, this one, that point right there in the middle. So angle T, so tan of T is equal to opposite over adjacent. So tangent of 4 is equal to 40 over X. So we end up getting X is equal to 40 over tangent of 4 degrees. So we end up getting X is equal to 572.0267. So let's go ahead and keep that in mind for now. Now we're going to work with this triangle on the left, or the right rather, getting my left and right confused today. And I've got my 7 degrees up here. Let's call this again angle T. And we've got my opposite side, which is the 40 meters, and the Y is my adjacent side. So once again, we are using the tangent ratio. So tangent of T is equal to opposite over adjacent. Tangent of 7 is equal to 40 over Y, and Y is equal to 40 over the tangent of 7. So we end up getting Y is equal to 325.7739. Let's move this out of the way a little bit, so I have a little bit of room to write here. So we're gonna go ahead and add X and Y together. So X plus Y, so we have distance is equal to X plus Y. So we have 572.0267 plus 325.7739, and we end up getting 897.8, and this would be in meters. So it doesn't really say what to round it to, so I'm just going to leave it rounded to the nearest tenth. So we can say the distance between the fires is 897.8 meters. So for the next 3 questions here, you can go ahead and pause the video and then unpause once you're done to check your work. I'm not going to go with a step-by-step guide, otherwise this video is going to feel like it's 3 hours long. So feel free to just watch at your own pace and let me know in the comments if you have any questions. So that's the end of today's video. Thanks again for watching, and I'll see you in the next one.